So after the installation of ADS, now we will see a basic introduction of the software. So basically ADS is an electric circuit design simulation and automation software. It offers an integrated environment to design a circuit. It includes an extensive library of components such as transistors, diodes, sources, transmission lines, and many more. So now we will see the interface of the ADS software. We will double click on it, open it. We will select ADS design environment here. And now we will close these. And now to design a schematic, we will create a new workspace. I will rename it as first, suppose, and create workspace. Now to create a schematic, I will click on window and then new schematic and then create schematic. Now basically to understand the interface, I will create here a low pass filter. So resistors, inductors and capacitor is found in lump components. So I will select lump components. When I click on resistor, it will be on my cursor until I press my escape key. So I will place a resistor here and then press escape key. Similarly, I will select capacitor. To change the orientation of the capacitor, I will press Ctrl R and place it here. Now to basically we also need a sources. I will use AC source. Now to drag a component, I will double click on it and I can drag it here. Now we can connect these by wires. So I will click on wire icon and then connect it. And now I will ground the remaining terminal. Now to extend a wire to a point where there is no terminal of any component, I will double click on that point. So I will double click here. This point will help us to measure the output voltage. I will add a pin here. I will name the pin as Vout. Now I will select here simulation AC and here I will select the AC component to help us in simulation. I will press the escape key again. Now I can if I want to change the values of a resistor, capacitor, any component, I can directly click here and can change the value. So I will choose the value 4700 ohms here and 15 nanofarad here. Now I can also change the starting and stopping frequency range. So I will keep here basically 10 hertz. Suppose we keep here 10 hertz and here I will keep 100 kilohertz. I will give step size of 100 hertz. I will press enter. Now the circuit is complete to simulate. Now for simulation we have three ways. Either I can click on simulate and then click here, or I can click on this gear icon, or I can press F7 key. So I will press F7 key directly to simulate. This will open this window. Now basically in this window we have three types of plots: rectangular plot, polar plots and Smith charts. So we can plot all these. So now to observe the behavior of the circuit with frequency, I will click on rectangular plot and then add it here. So I will click on Vout and add. So I will basically it is a complex value. So it is asking us that how we want to plot it on the graph. So I can select decibel also, but I will for simplicity I will select magnitude and then press OK. Now we see that it is behaving like a low pass filter because it attenuates the higher frequencies and it allows low frequencies to pass. but we can make it clear by double clicking on it, and I will change the scale on the x-axis to log scale. Now we can clearly see that it is now clearly visible that it is acting as a low pass filter. It is alternating higher frequencies and allowing low frequencies to pass from the circuit. Now we can also observe the behavior of the circuit by changing the values of the resistors and capacitors. So for this, we can either select this tuning option here, or we can also select tuning from simulate and then tuning. Now it will ask us to which components we need to tune. So I will select resistor, press tick, OK, and capacitor. Now I will also, so now we can see that if we change the values of the resistor, the value of the cutoff frequency is changing. And we can also see that if we change the value of capacitor, the value of cutoff frequency is also changing. Now to go back to the original values that we started, we'll press on the close icon and press no. So it will restore the original values. So now we can basically see that it is acting like a low pass filter. So now it is the basic introduction of the interface of the ADS software. We will create new exciting circuits in the ADS software later on in the workshops. Now I can save it by clicking yes, okay, and then yes. Now to delete a workspace, we can click on file and then click on close workspace. First we need to close the workspace and then again click on file and delete workspace. I will select the workspace, first workspace, and select folder. It will delete the workspace that we created. Okay. Now it is similar, like we can create new workspaces and can create our own schematics. So thank you.